So these are the tools you're going to want to have handy for removing the nozzle and clearing any kind of a blockage if your filament broke and you're having a hard time getting it to feed through. These are parallel jaw plier wrenches. You can also use channel locks. The goal for this is that we want to be able to grab the 3 brass standoffs on the print head without damaging the wires. And it's going to be hot, so we don't want to use our hands. So that's what this is going to be for. So I can just grab it like that and immobilize it. You want a 2.5 millimeter hex driver. Ball end is usually easier for what we're going to do. Phillips 1 screwdriver to take the cooling fan off. And I've got both a wrench and just a driver in a 1/4 inch size for the nozzle. Sometimes it's on there tight and you have to break it free with the wrench. Other times you can just put a driver on there, like we'll probably do today, and just take that bit off. Just like that. And use the same thing to put it back on. Remember, these are going to be at 235 degrees C when we take them out of the printer. They'll cool off fast, but they'll still be dangerous. We also are going to use tweezers to pull out the filament from the bottom, and I'm going to use a brass brush just to clean off the nozzle while I have the cooling fan off. Okay. We're going to go into how to clear a clog on your MK1-250 print head. Normally when you change filaments, you heat up the print head to the temperature of the filament that's currently loaded, and you use this little lever here to back out the filament until it swings freely, and that'll have emptied it all the way down to the fusion chamber down here. However, sometimes people have brittle filament, or they're in a hurry and they pull it and your filament snaps, which is what's happened here. I don't know if you can see it, but this was previously loaded with some red filament, and there's a little bit of red showing between above the top of that white guide tube and beneath the hobbed shaft of the motor. Can you see that? Okay, so what we're going to do is we're going to force it through with some blue filament. So normally if this would happen, what I would do is I would heat it to the temperature for the material, which is ABS, so 235 or 240. I would take my new material and guide it through like this, if you can see that, and just force the molten remainder. And sometimes you have to assist it because it's broken right off at the teeth, but the user that's called us in this problem doesn't have any success with this. So what we're going to do is we're going to heat it up, we're going to disassemble it partially, and then we're going to use the printer to drive the other material through with no resistance from a nozzle. So a nozzle is the most restrictive part of the whole delivery shaft. So that's what we're going to do. So first I'm going to have to heat this up to 235 or 240 because there's a remnant of ABS in there. So we'll swing over to the printer. And we'll heat him up. Now this one actually has a little piece of tape on the end just so that I can see that the motor is spinning when it spins. Here I'm advancing the filament at 100 pulses per second just to get it started right. Alright, we're approaching 235. The reason we want to heat this up is because we don't want to have hard plastic which may be seated into the PTFE, or the white Teflon guide tube. When we're rotating the nozzle, we don't want to break off any of that Teflon. So we always want to do any assembly or disassembly, especially if it's adjacent to or touching the Teflon parts, while the head is at temperature. Get another few degrees here. Okay, so I'm going to put my emergency stop in just for safety. I'm going to pull out my head, and you can see the material inside has expanded a little bit. And so there's a little string of ABS coming out the bottom. So now I'm going to take first I'm going to use my hex driver. I'm going to remove this fan because it's going to be in the way for taking the rest of these parts apart. Now this could have been done ahead of time unless there's some molten ABS that had it seized up. And it looks like this would have been okay. So the fan's off. Now I'm going to expand my little pliers, not that far. I'm going to grab just like this, so you see I'm not impinging any of the wires, but I have a firm grab Now I'm going to use my driver to rotate out my nozzle. There we go. You see some remnant ABS down here still in the fusion chamber, but the rest of this should be pretty clear. What I'm going to do now is put this back on. Alright, so we're in a different slot. I have better access to see in through the side. Use my filament to try to push a piece of red into the guide shaft. Seems like I've got it lined up. Let's speed it up a little bit. And there comes the remainder of the red right out the bottom. And you can see this is really wide. That's probably 2 millimeters wide, which is the internal diameter of that guide tube. And there comes the blue without even melting. So I'm going to turn that off now. I'm going to back the entire blue filament up. You see it going up. And we always let it drive itself past the motor shaft, and when it stops moving, it's ready to come out. So this is the part that actually went through. It didn't melt because it just came through the Teflon tube and straight down the center of the hot area. Now that our path is clear, we're going to take this guy out. We're going to attach the nozzle back. We want to make sure that the outside of this is clean in the top, because this is going to seat up in against the bottom of that PTFE tube. So let me take a second to show you what that looks like. This is a cutaway of this portion of the printer, of the nozzle. So you can see that the brass nozzle, let me use my other driver. The brass nozzle threads in and the top of it mates with that Teflon tube. So that's why it's critical that there's no excess plastic residue at the top or on the outsides of this brass nozzle, because that'll give you mating issues and then you'll have clogs in the future. So we're going to go ahead and put this one back in. On the real one, it's already cooled down somewhat. It's been sitting out for several minutes, but there's nothing on the outside except some discoloration. So we're going to again grab this with our wrench, making sure that we're not deflecting any of those wires. And we're going to take our nozzle, you should make it snug, but you don't want to break anything. The nozzle's in place. Now we can reattach our fan. And my little peak nozzle came off my fan. This is a good time to clean it. If you need to clean it, you can heat it up and use a wire brush. Let's see what we've got here. Let's get some debris. Sometimes some ABS or whatever filament you're using, some material will sneak up in there. So we're going to put this back on. We're going to load our screws. Get them lined up just right. One side and the other. You always get both screws started before you tighten either of them down when you're doing something like this. And then I can reposition my little fan nozzle. You want a good millimeter clearance between the bottom of your brass nozzle and any part of your fan assembly. And now this should be ready to go. So we're going to load them back up. Slide them out here where you can see it. We're going to heat them back up. And then we're going to load some fresh filament. We'll load some red filament again. This one's a little brittle. This one's really brittle. So just going to let him get up to temperature. So I'm going to turn my motor on, and it's at 100. Normally I advance stuff at 500, so we're going to have our motor turned on manually at 500. We've got a few inches exposed. I try to straighten out the last inch or so. I usually observe through this observation port on the left as I put my filament in and get it, whoops, this is very brittle. So I'll line it up with the hob portion of the teeth, and the bearing should keep its center, oops, and it should go right into that white Teflon guide tube. And it's already got it. So I'm just going to allow it to feed, and I'm going to seat the guide tube here. I'm just going to wait for our fresh filament to come out the bottom. It may take a couple of minutes because it has to cover that entire gap, and it's going very slow. And here we come. You can see that right there. I always run about a foot and a half. I look for a uniform thickness, color, smooth sides, just that there's no aberrations in it. And we should be ready to print. For more information, reach out to us. You can find us online at hyrel3d.com or hyrel3d.net. We're always here for you.